Hello, welcome back to Learn Physics. In today's topic, we are going to continue with sound. In last video, we finished all the theory portions of this chapter. Okay, now we are starting with the exercise questions. Okay, so here in page number 162. How does the sound produced by a vibrating object in a medium reach your ear? How the sound produced by a vibrating medium will reach to our ears? Yes, so a vibrating medium is the source for sound, isn't it? So that source of sound will be producing sound. That time it will pass through the medium, because it will vibrate. It will make the medium to vibrate and transfer the energy from one particle to the next particle. So here the transferring energy. So if suppose this is the source, from here it will transfer the energy to the next particle, and that will be transferring the vibration to the next particle. Then this vibration will stop. Okay, this will start vibrating, and then next particle, like that it will go on. Or we can say the sound wave will be traveling as compressions and rarefactions. That also correct only. Okay, it will be traveling as compressions and rarefactions. Okay, so next one is in page number 163. Explain how sound is produced by your school bell. So here nowadays in all this, most of the schools it is like it's electric bells. Okay, so this one is old kind of bell only they are asking. See, one round color iron disc will be there, and a hammer will be we will be putting the hammer on that sound will be coming. Okay, so that kind of school bell only they are asking. Okay, so in that one, how while we are it's putting the hammer on that disc, what will happen? Vibrations will be there. So that it will start vibrating. That vibrations will be it's producing the sound waves. Okay. So then next is, why are sound waves called mechanical waves? Because sound wave needs medium for traveling. That is why we will call the sound waves as mechanical waves. Okay, next is, suppose you and your friend are on the moon. Will you be able to hear any sound produced by your friend? You and your friend is there in moon. So whether you will be able to hear any sound? No, because moon has no atmosphere. So atmosphere is not there. So medium is not there. So there is no medium for the sound wave to travel. So we can't hear the voice. Okay. So the next one is in page number 166. First one, which wave property determines the loudness? Loudness determines the, yes, amplitude. Loudness means it is, isn't it? Loud sound means we will do it like this. Loud. Isn't it? If it is soft sound means we will do it like this. So it is loudness determine the amplitude, and pitch determine frequency. So high pitch sound means frequency will be more. Isn't it? This is high pitch sound, and low pitch sound means it will be like this. Frequency is, so even if the amplitude is same, but the frequency will be different. Okay, so pitch determines the frequency of a sound wave. Okay, then guess which sound has higher pitch, guitar or car horn? Guitar has higher pitch, isn't it? Then next, the frequency is more for guitar than the car horn. Car horn amplitude is high, that is loudness is more. Okay, then next is, what are wavelength, frequency, time period and amplitude of sound wave? Wavelength means length of one wave, that is distance between one crest between the two consecutive compressions or rarefactions. See, this is compressions, and or distance between the two consecutive compressions or rarefactions, or we can say distance between the two trough or crust. This is crust and this is trough. Or in as compressions and rarefactions, while we are representing, it will be compressions. This is rarefactions. Then again compressions. So distance between the two compressions. Two nearby compressions, that is consecutive compressions or two consecutive rarefactions. They are called as wavelength, length of one wave. Okay, that is wavelength. Frequency is number of waves in 1 second. That is number of waves traveling through a particular point in 1 second is called as frequency. Next is time period. Time period is the time required for a wave to travel through a particular point. For traveling one wave, what will be the time required? That is called a time period. Okay, so next is amplitude. Amplitude is the maximum disturbance of the wave from the mean position. This is called amplitude. Okay. Next is, how are wavelength and frequency of a sound wave related to speed? Speed equals frequency into wavelength. This is the formula for finding out the speed, frequency and wavelength. How it is related? V is equal to nu lambda. Calculate the wavelength of a sound wave whose frequency is 220 Hz and speed is 440 meter per second in a given medium. That is, wavelength is given as wavelength. Calculate the wavelength of a sound wave. We should calculate the wavelength. Okay, whose frequency? Frequency is given as 220 Hz as the frequency, and its speed is given as 440 meter per second. And we should find out the wavelength. What is the relation connecting V, nu and lambda? V equals nu lambda. Okay, so lambda equals V by nu. V is 440 divided by 220. So we will get it as 2 meters. Okay, this is the wavelength of the wave. Okay, then next is fourth one is, this is third one, and next is fourth one. Fourth one is, a person is listening to a tone of 500 Hz sitting at a distance of 450 meter from the source of sound. What is the time interval between two successive compressions from the source? That is, time interval between two successive compressions means it is called a time period. We should calculate the time period. For that, it is given as, frequency is given as 500 Hz, and then it is sitting at a distance of 450 meter from the source. So the distance is given as, distance is 450 meter. What we need to find out? Time period. What is the relation connecting nu and t? T is equal to 1 by nu. That is 1 by 500. That is equal to 0.002 seconds. Okay, clear? Next is, distinguish between loudness and intensity of sound. See, loudness is the characteristic property of a sound wave. Okay, and it depends on amplitude. Loudness depends on amplitude. It differs from person to person. Okay, it is relative. That is, for me, if it is a loud sound, for you it won't be a loud sound. Okay, these are the properties of loudness. Okay, then next is intensity. Intensity is the number of waves passing through unit area. That is called intensity. That is, if the number of waves are more, intensity also will be more. Okay, and it is not relative and all. It is independent of any other thing. Person to person, it won't be changing. Okay, so that is called the intensity. So next one is in page number 167. In which of the three media, air, water and iron, does sound travel fastest at a particular temperature? So sound will be traveling faster in solids, then in liquids and least in gases. Okay, so temperature is constant. So here, which is the solid, air, water and iron? Iron as a solid, so it will be moving faster in iron. Okay, so next is, an echo was heard after 3 seconds. What is the distance of the reflecting surface from the source, given that speed of sound is 342 meter per second? So it is from page number 168. Okay, first question. An echo is heard after 3 seconds. T is given as 3 seconds. What is the distance of the reflecting surface from the source, given that speed is given as 342 meter per second? So what is the formula to find? How we will be finding out? Distance only we need to find out, isn't it? Distance, to calculate distance, velocity equals distance divided by time. But here, distance divided by time. To hear the echo, it will, if the source is here, it is to hear the echo, it will be going, reflecting and coming back. So if this is D, this is also D. So what is the total distance covered? It is 2D. 2D divided by T. So 342 equals 2 into D divided by 3. Okay, so it is 342 into 3 divided by 2 is D. So it is 171 into 3. So that is equal to 513 meter. Okay, so that is how we will be finding out. So don't forget to put 2D. That is the only thing you should remember over here. Then next is in page number 169. Why are ceilings of concert halls are curved? Why ceiling of concert halls are curved? See, if it is a curved one, what will happen? This is the source of sound. From this, sound is coming. It will go here, reflect, and it will go to all the corners. Okay, this is the reason this concert halls are of curved shape. Okay, so next is, what is the audible range of average human ear? 20 hertz to 20 kilohertz. Okay, then what are the range of frequencies associated with infrasonic sound? Infrasound means it will be below 20 hertz and ultrasound means it will be above 20 kilohertz. If it is above 20 kilohertz, it will be ultrasonic sound wave, and if it is below 20 hertz, it will be infrasonic sound wave. So next is a numerical. A submarine emits a sonar pulse which returns from an underwater cliff in 1.02 seconds. If the speed of sound in salt water is 1531 meter per second, how far away is the cliff? So submarine is giving a sonar pulse. So it is giving a pulse. It is reaching to the cliff and coming back. It is just like echo only. Here it is given as the time required is 1.02 seconds and speed is given as 1531 meter per second. So we need to find out the distance. Total distance travelled is 2D divided by time. So 2 into D divided by 1.02, that is equal to 1531. So how we can find out D here? 1531 into 1.02 divided by 2. So it is 0.51, and we can calculate that 1531 into 0.51 we can find out. So we will get it as 780.81 meters. Okay, so this is how we will be finding out the distance. Clear? So this chapter is not that much numericals and all, only some 2-3 formulas you should remember. V equals nu lambda, nu equals 1 by t, and V equals 2d by t in the case of sonar as well as in echo. Okay, these are the main this numerical part of this chapter, and the graphs related to all this compressions, rarefactions, loudness, pitch, all those things you should learn. Okay, so I hope all of you understood all those things, and next video we will be coming with the NCERT exercise questions. Okay, if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.